Today we're going to be looking at circuit elements. So we have an RC circuit that has a 6-volt battery, a 1 kilo ohm resistor, we have a switch, and then we have a capacitor that has 100 microfarads. So at time equals 0, there is no charge on the capacitor, but at time equals 0, the switch is closed, which allows the capacitor to begin to charge. So our question is, at time equals 0.15 seconds, what is Q, what is the voltage across our capacitor, what is the voltage across our resistor, and what is the current inside of the RC circuit. First thing I did is I just converted the 100 microfarads to regular farads, which is 100 times 10 to the negative 6 farads. I converted 1 kilo ohm to ohms, which is 1,000 ohms. So the next thing we want to do is we want to find the Q at time is equal to 0.15 seconds. So if we look at our RC circuit, it's in a series, so we can use the equation for our charge in a series RC circuit, which is this Q is equal to the EMF times 1 minus E raised to the negative T divided by RC. RC is given by the resistance times the charge, so 1,000 ohms times 100 times 10 to the negative 6 farads is equal to 0.1 seconds. So we can substitute the charge of our capacitor times our EMF, and then 1 minus E to the negative 0.15 seconds divided by 0.1 seconds. The 0.15 seconds, this comes from our T, at what time we're looking for. And then we get the charge is equal to 4.66 times 10 to the negative 4 coulombs. In order to find the voltage across our capacitor, we can use the equation the voltage across our capacitor, the maximum voltage of that, times our 1 minus E raised to the negative T divided by RC. The maximum voltage that our capacitor can have is 6 volts, since we only have a 6 volts battery. So we just do 6 volts times 1 minus E to the negative 0.15 seconds divided by 0.1 seconds, and we get 4.66 volts. In order to find the voltage across our resistor, we have to use the conservation of energy principle, which means that the voltage across our capacitor plus the voltage across our resistor must add up and equal the voltage across our battery. So then we can solve for our voltage across our resistor, which is equal to the voltage across our battery minus the voltage across our capacitor. So 6 volts minus 4.66 volts is equal to 1.3 volts, and that is the voltage across our resistor. In order to solve for I, we can use the equation for our current in a series RC circuit, which is I is equal to EMF divided by our resistance times E to the negative T divided by RC. So I is equal to 6 volts divided by 1,000 ohms times E to the negative 0.15 seconds divided by 0.1 seconds, which is equal to 0.0013 amps.